let us see lung volumes and capacities. Now, before we start off, let us see what we use to measure these lung volumes and capacities. So we use an instrument called as a spirometer. Spirometer is the instrument that we use to measure the lung volumes and capacities. Now, the amount of air that is present in the lung, a part of it can be modified using various breathing techniques like shallow respiration, forced respiration. That means that part is under our voluntary control. Whereas there is another part which is not under our voluntary control, and this is an involuntary part which we cannot measure using a spirometer. So here we see that there is an involuntary part which we cannot measure using a spirometer, and there is a voluntary part which we can measure using a spirometer. Alright, now let us go to see various lung volumes. When we go to see lung volumes, we will first start with quiet respiration. What happens when a person is breathing quietly? He will take in some amount of air and he will give out some amount of air. So there will be inspiration and expiration. So the volume of air that is inhaled or exhaled during quiet respiration is called as tidal volume. I repeat, the volume of air that is inhaled or exhaled during quiet respiration is called as tidal volume. In a normal person, it is usually 500 ml. Now, let us see what happens when a person breathes in forcefully. When a person breathes in deeply or breathes in forcefully, he will definitely inspire more air as compared to when he is breathing quietly, which means that he will inspire more air over and above the tidal volume, and hence the volume of air that can be inhaled over and above the tidal volume is called as the inspiratory reserve volume. And in a normal person, it is usually anywhere between 2500 to 3000 ml. This blue line shows us the inspiratory reserve volume. Alright? Blue line shows us the inspiratory reserve volume. Now, what happens when a person is expiring forcefully? When the person is breathing out forcefully, what happens is that he breathes out air over and above his tidal volume, and hence volume of air that can be exhaled over and above the tidal volume is called as the expiratory reserve volume. It is usually between 1000 to 1100 ml. Now let us see. This is the tidal volume. This is the point which signifies normal inspiration. This is the point which signifies normal expiration, and everything beyond this point, which is signified by the brown line, indicates expiratory reserve volume. It is usually between 1000 to 1100 ml in a normal person. Now, what one can see from this graph also is that in spite of forceful expiration, this person has not been able to expire the entire amount of air from the lung. So, some amount of air still remains in the lung in spite of forceful expiration, and this is the residual volume. So, what is the residual volume? It is the volume of air remaining in the lung even after forceful expiration. In a normal person, usually it is between 1100 to 1200 ml, and this is the involuntary part. This is the involuntary part, and hence it cannot be measured by the spirometer. So this is what you see. This is the residual volume. Now, with this information, let us just summarize the various lung volumes. So, there are certain volumes which can measure by spirometry. These are voluntary, and certain volumes which cannot be measured directly by spirometry. This is involuntary, that is the residual volume. Now, when we are doing spirometry and when we ask the person to breathe quietly, we can measure the tidal volume. When we ask the person to breathe in forcefully, forced inspiration, then we can measure the inspiratory reserve volume. And when the person is asked to breathe out forcefully, that is forced expiration, then we get the expiratory reserve volume. So this is how we get the various volumes. Now, let us go to lung capacities. Lung capacities are basically addition of two or more volumes. Alright, so let us look at various lung capacities. Let us start with inspiratory capacity. It's the total volume of air that a person can inspire after a normal expiration. Now, what is our starting point? Starting point is normal expiration. So let us look at where is the normal respiration. The moment they say normal, we look at the tidal volume. Okay, the top part of the tidal volume is the normal inspiration, and the lowest part of the tidal volume is the point for the normal expiration. So we need to start from this point, and it is the total amount of air that a person can inspire. The moment they say inspire, we have to go in the upward direction. So we track the entire tidal volume, and we also add this part, which is the inspiratory reserve volume. And hence, inspiratory capacity is tidal volume plus inspiratory reserve volume. This is how we get inspiratory capacity. Now, in your NCERT textbooks, they also mention something called as expiratory capacity. What is that? That is the total volume of air that a person can expire after a normal inspiration. So, this is normal inspiration. This is the point of normal inspiration. So, the total amount of air that he can expire. So, downward direction. You add tidal volume and you add this part, which is the expiratory reserve volume. So, EC, that is the expiratory capacity, will be equal to tidal volume plus ERV, that is expiratory reserve volume. Alright, then we go to see something called as a functional residual capacity. It is the volume of air that will remain in the lung after a normal expiration. So where is normal expiration? Again, look at the tidal volume curve. This is our point of normal expiration. So this is our starting point, and we want to see the amount of air that will remain. So this is the amount of air that will remain. Now it has got two components. It has got a voluntary component, that is the expiratory reserve volume, and it has got an involuntary component, that is the residual volume. So functional residual capacity is equal to expiratory reserve volume plus residual volume, that is ERV plus RV. Now we go to another important capacity, and that is vital capacity. What is vital capacity? It is the maximum volume of air that a person can breathe in after a forceful expiration. So what is our starting point in this? Forceful expiration. So this is our starting point, forceful expiration. And amount of air that a person can breathe in. So we need to go in the upward direction. Alright. So we start with this. This is the expiratory reserve volume. This is the tidal volume. And this is the inspiratory reserve volume. So in short, we are measuring this particular line. In short, we are measuring this particular line, which gives us the vital capacity. Now, if we are anyways measuring this line, we can also look at it from the other point of view, and that is vital capacity is the maximum volume of air that a person can breathe out after a forceful inspiration. Alright, so this is our point of forceful inspiration. What we get is inspiratory reserve volume, tidal volume, and expiratory reserve volume, which means that basically we are tracing the same line. Only thing is we have altered the definition slightly. Now, this